Good morning to everyone who participate in these webinars. I'm Yule here. Today I would like to present and share with you about for the analysis of disinfections byproducts, which is called the DBPs in the short form in drinking water. Later, if you have any questions about means that this webinar, you can write or ask your questions in the later means that I will try to answer your question in the Q&A sessions. Before I go to start with this topic, I would like to share with you this slide of means that introduction to ALS.
This is a photo of our building, which is also ALS Malaysia's headquarters in Bukit Jelutong Shah Alam, Selangor. Before we start, I would like to show this slide as a reminder of safety in everything you do. We uphold and practice a culture of safety as safety is one of our ALS core values. In this time of COVID-19 difficulties, please practice safety first culture in everything you do. ALS stands for Australian Laboratory Services, and its history started back in 1863, originated from Brisbane, Australia. We have presence in more than 65 countries with 400 plus laboratories worldwide, employing more than 13,000 people. In Malaysia, the management is headed by our General Manager, Dr. Tin Tin Tin, with a total staff strength of about 200 people. We have a total of 4 laboratories in Malaysia with the HQ in Bukit Jelutong, Shah Alam, Selangor. Up north we have a lab in Penang, down south in Johor Bahru, and East Malaysia in Kota Kinabalu. All our laboratories are also MS ISO 17025 accredited for food chemistry, microbiology and environmental testing. We also have 2 sites offices at Kemudian and Ipoh. ALS Malaysia has garnered several recognitions over the years as a certified MS ISO 17025 laboratory. We are the recognized panel laboratory for National Pharmaceutical Regulatory Agency, Ministry of Health and Food Safety Testing, Jagim's Halal Panel Laboratory, Ministry of Environment and Water. Certified GMP Plus Laboratory for Heavy Metal, Mycotoxins and Pesticides Testing. We are also the Biodexis Partner Laboratory for Bioeconomy Malaysia, providing testing services for all the Biodexis companies in Malaysia. ALS Malaysia was also awarded the IKM President Laboratory Award year 2017 to 2020 in the category of Best Commercial Testing Lab. These are some of the certificates that I mentioned from the previous slide.
Okay, today the learning objective for this is upon completion of these sessions, the participants will be able to know the occurrence of the DBPs in drinking water and what are those common regulated DBPs in drinking water, and descriptions of the DBP analysis in drinking water, and lastly will be the quality control procedures for the DBP analysis. Okay, drinking water, including bottles and tap water, may reasonably be expected to contain at least small amounts of some contaminants. In United States, okay, the EPA set strict standards for approximately, I think, about 90 different types of contaminants that can be found in drinking water. But today, I would just like to share with you what are the most common water contaminants in our daily drinking water. You can see in this slide, radionuclide is one of the common water contaminants. Apart from that, VOC, some heavy metals like arsenic, and the disinfectant here, it can be like, for example, the chlorine. And of course, there will be some of the microbes, organisms, or bacteria. And the one that I want to share with you is the disinfectant byproducts, which is called the DBPs. In the daily waters that we drink, normally it's like go through the disinfectant process. So why are the disinfectants are used in drinking water nowadays? Okay, because drinking water, they contains varieties of the viruses, bacteria, and other organisms. So that's why that we need to add the disinfectant to water and kill them. And there are actually many types of different disinfectant process. Okay, one of it will be the chlorination process. And chlorine is most widely used as a disinfectant because chlorine compounds will destroy most of the disease-causing organism quickly. Okay, it usually after the 30 minutes. Okay, what are the disinfectant byproducts here? So the DBPs are the chemicals, whether it's either organic or an inorganic substance that can be formed during the reactions of a disinfectants. For example, here be the chlorine with the naturally present organic matters in the water. So if you're drinking water in the presence of the organic matters and also the disinfectants, it will react and get the disinfectant byproducts. Chlorination is one of the types of the disinfectant, but you can other example that ozonation process. The ozonation process, it might produce the bromate. Okay, for the chlorinations, with the treatments of the chlorine or chloramine, it will produce the inorganic substances like the chloride, chlorate, and also the organic substance like the trihalomethanes and haloacetic acid. So what will be happen if, let's say, for example, you add chlorine into your water for the drinking water system? Okay, not just only it means that it will oxidize the organic acids or organic metals in the drinking water to produce the DBPs. Not just only that, it might be react with organic nitrogen, okay, to produce the chloramines or combined chlorine. And you also sometimes it will oxidize inorganics like the iron and manganese. Of course, there will be some free chlorine present in your drinking water as well. Like for example, there might be the presence of the organic substances of DBP, such as the trihalomethanes. So these chlorines will react with the organic metals in the drinking water to produce the THM. So what are the THM here? So you can see the THM here consists of 4 compounds, organic compounds. It can be chlorine, bromodichloromethane, dichloromethane, and bromoform. Okay, why the DBPs are so concerned to our environment, that in our drinking water? Because this DBP is harmful to our human body and human health. So what are the health effects of DBP in drinking water? And most of these compounds are carcinogenic, so it may cause like bladder cancers. And this DBP in the US, they're linked to like about 9,300 US cases every year. And also it cause other cancers like rectal or colon cancers. Not just only that, it also affect the reproductive and development systems. And like for example, the neural tubes defects or miscarriage and low birth weight. And also some others concerns will be like the kidney or spleen disorder, and also you affect the immune system problem, neurotoxic effect. So you can see that this DBP means that it's very harmful to our human body. That's why we need to monitor these DBP products in our drinking waters frequently. According to the nationwide DBP occurrence study in the US, okay, they do these studies to measure or some of the all the DBP's products in the water across the US, and then they found out that they prioritize more than 600 unregulated DBPs, okay, reported in the literature, and likely they will cause cancer. And what are the important findings they find through this study? Okay, the first, there are new emerging DBPs identified. Okay, so these new emerging DBPs, it can be like, for example, the halonitromethanes, haloacetonitrols, halofurananes, or iodo acids such as iodoacetic acid, okay, which is not commonly regulated in the guideline. Okay, and the second one, they found out that the alternative disinfectants, okay, increase the formations of many priority DBPs. So it means that it's not just only the chlorination process for the drinking water, there are alternative disinfectants process, okay, such as, for example, you have like ozonation process, or you add the chlorine dioxide instead of the chlorine, or you use the UV to kill, means a UV process for your disinfectant process. And third, many priority and unregulated DBPs are found at significant levels. So you can imagine that there are so many DBPs compounds in your drinking water that you might not know, and it might be cause some health issues to the humans. So that's why it's very important that means that every country they have their regulated guideline to monitor these DBPs compounds. Okay, when it comes to the DBPs in drinking waters, okay, experts have identified more than 600, okay, disinfectant byproducts, but only 11 of them are regulated today. So what are the comments that the 11 comments disinfections byproduct? Okay, they are the trihalometanes, okay, haloacetic acids, bromate, chloride, and chlorate. Okay, this table shows you the US EPA regulated DBP guidelines in their drinking water. For the total trihalometanes, there are a total of 4 compounds here. And for the 5 haloacetic acid, also 5 compounds. And then bromate and chloride, in total up of this compound will be total 11 compounds. So these are the 11 common DBPs that means that regulated in US for their drinking water. So you can see the concentrations for the guidelines. And I would like to show you this table is a comparisons, okay, guideline across means that the WHO guidelines, US EPA drinking water guidelines, and Malaysia Food Act guidelines. Okay, you can see for the Food Act guideline in Malaysia, means that the DBPs compounds that monitors will be less, okay, compared to the WHO guideline and US EPA guideline. Okay, for the Food Act, they just monitor the trihalomethane compounds. Okay, and whereas for the WHO guideline and EPA drinking water guideline, okay, they will actually monitor for the haloacetic, include the haloacetic acid and also the oxyhalides. What is the difference for the US EPA drinking water guideline and WHO guideline? Okay, for the US EPA drinking water guideline, for the total trihalometanes, they actually added all the 4 compounds, organic compounds. For their guidelines will be 80 ppb. It's a summation, okay? So that's why it's called total trihalomethane. But the rest for the WHO or Food Act, they are the guideline is for individual compounds. Same as for the haloacetic acid. Okay, for US EPA drinking water guideline, they also is a summation of the total of 5 haloacetic acid. And for the WHO is means that with the individuals limits. Okay, for the oxyhalides, by the Food Act also didn't means a monitor for the oxyhalides, but whereas these two, WHO and US EPA, they are monitor for the concentrations. So you can see for the Food Act 25th schedules, the guideline limits, okay, is lower compared to the rest of the guidelines. And this is another national drinking water quality guideline, which is recommended to use for our means a water system in drinking water in Malaysia. Okay, so for this guideline, okay, haloacetic acid and oxyhalides are monitored. Okay, not like the Food Act guideline. And these trihalometanes, normally they need to monitor quarterly per year. And whereas for the haloacetic acid and oxyhalide, they just need to monitor when necessary. So you can see that one because of the concern of the DBPs, they are means that guideline, they come up with means that the maximum allowable limits in the drinking water to ensure means that the consumer their drinks are safe, means that safe drinking water. So I would like to share with you the ALS reference methods and analysis technique for this common DBPs compound. Okay, for the trihalometanes, we are using the US EPA method, which is 8260B. The analysis technique is using the GCMS purge and trap. Whereas for the haloacetic acid, we are using the in-house method based on the German method, which is the DIN 38407. It's using the LC-MS, LC tandem mass spec, or called the LC triple quad. Whereas for the oxyhalides, we are using reference method based on USEPA 300.1. The analysis technique here will be using the ion chromatography. Yeah, this is the gas GCMS purge and trap, okay, that we will use for the THM analysis. This is the chromatogram for the THM, so you can see 4 different compounds with 4 different peaks. And for the haloacetic acid, we are using the liquid LC triple quad for the analysis. And this is a chromatograms of the MRM for each of the acetic acid compounds. So you can see it for the different acetic acid compound. You will use the different MRMs ions to monitor. This is the ion chromatography, which is used to analyze the oxyhalide, means bromate, chloride, and chlorate compounds. Yeah, this is the examples of the oxyhalides. So you can see chloride, bromate, and chloride, and the rest of the compound, it can be others anions compounds. Okay, now is for maybe for 5 minutes time for break. If you have any Q&A questions about regarding just now the DBPs, the analysis method, or the regulated guidelines, or anything that you're related, you can ask you can ask me here. Yeah, Q&A. Oh. Okay, I get these questions from: which is safer, effective, and healthier? The RO, alkaline as example, alkaline cocoa, or UV treated and made drinking water. Okay, because I can't really answer your questions for this, because each of this system, it will have a different how to say the process to produce the drinking water. So if you want to know that whether it's safe to drink, you need to actually get the samples of each of this different means that drinking water from this different system, and then send for analysis, for drinking water spec analysis. So if you means that pass through all the guideline for the drinking water spec, then it might be like you are confident that you will drink that water is safe. But now I can't, because I don't have the data for all these 3 different water testing. Another question: so far, does Malaysia drinking water contains haloacetic acid and oxyhalide that comply with WHO? Yes, some of the clients, they are send their drinking water to follow the WHO guideline, which is more stringent and can more compounds to monitor. So far, yes, means that some of the that means that the waters means that for the haloacetic acid and oxyhalide means that complies with the guidelines, that comply with the WHO guideline. Okay, another questions here. Good morning. Noted that chlorine is most widely used as disinfectant. Okay, is there any control limits of chlorine residue in chicken raw material as per EU regulation? Is there any control limits of chlorine residue in product as per EU? Sorry that this I don't think I can answer this questions because we don't, because this one, I think the chlorine dosing. Okay, if according to EU regulations, the maximum residue level for the chlorate per kg of food, it should be about 0.01 mg of chlorate. Means that it's a 0.01 mg per kg. ppm at 0.01 ppm. Means that for food samples. So if you want to know whether the chicken raw material is comply with the EU regulation, so you need to actually test the chlorine residue in your chicken raw material. Another question here. Since certification in Malaysia need to do annually to test water, is it compulsory to test other than stated in 25th schedule? The 25th schedule is meant for those food manufacturing, because this one is related to the Food Act. Okay. Other than the 25th schedule, you can actually means that you can reference to the WHO guideline, because the WHO guideline, it consists of a lot of parameters that can be monitored, which is more thoroughly, which is more comprehensive, because we have clients actually not just only do for the 25th schedule, because the 25th schedule is just a basic, okay? You can say the basics test parameter that you need to test to monitor the drinking waters. But if you want to go for the thorough one, you can actually reference to the WHO guideline. Another questions. Do your lab can help to analyze the chlorine dioxide approval guideline that our Malaysia serum can be identified? So far now, currently we don't actually offer for the chlorine dioxide analysis. Instead for the approval of guideline, sorry that we don't offer this test, but we can analyze for the chlorine residue in the drinking water. Okay, another questions for you. What is the occurrence of DBP in Malaysia? Okay, means that the occurrence of DBP is something that formations. Okay, how's the DBP is formed? Okay, in your drinking water. So like what I mentioned in my introductions in my slide, the DBP products is formed, okay, during the chlorination. It means that the disinfectant process. So if let's say your disinfectant is chlorine, when you add it to the drinking water, so it will react, this chlorine, it will react with the organic matters in the drinking water to form the DBP products. So the DBP products here, actually you have, in the worldwide, okay, you have more than 600 DBP products, but only that 11 DBP products are commonly found and also regulated in the guidelines. Okay, another questions. WHO regulation level, although cover more but less stringent than compared to Schedule 25th. Yes, I agree with you. The 25th, Schedule 25th, for especially for the trihalomethanes is more stringent. They have a lower limits. But if you just only analyze only the THM, it's just only one part. Okay, it's just only one portion of the DBP products and disinfection byproduct. But if you, according to the WHO, it has actually more parameters, because the DBP is not just only the trihalometane. It can be others. Okay, like for example, you have haloacetic acids, you can have oxyhalides and others DBPs compounds. They that are actually covered in WHO regulation. So it would be good if your drinking water is compliant with the WHO regulation, because it's covers more comprehensive test parameter to monitor. Okay, one more question here. Cause I found difficult to obtain the chlorine dioxide register in serum, as they do not have method to analyze or regulate it. Oh, okay, I see your it's a situation, but we also actually didn't do the chlorine dioxide in our lab. Okay. Okay. Thank you for all the questions here. Now I would like to continue with my slide for the next sessions, where we talk more about the process flow in our lab and also the QA/QC that practice in our lab. Okay. Sorry on the floor, maybe some technical issues. Please hold on for a while. Okay. Sorry. Thank you for your patience. Okay. Okay. I would like to share with you means that the lab quality system or management that means that we practice in ALS. So laboratory, I would like to highlight that is that laboratory data quality is very important, that the lab can produce the results in an accurate and reliable manner, so that our clients will receive means that accurate and reliable results. So how to maintain in a lab? So how to maintain the laboratory data quality? Okay, then in ALS, our lab. This is the you can see this one is our management pyramid, quality management pyramid that we practice in ALS lab. We have a strong quality base to support our clients with the quality results, and we have, like you can see the base that we have, because we are accredited with ISO 17025. So we have a series with the documentations, like we have policies, we have the SOP, we have the QWI for each of the process, and also each of the methods that we analyze. Okay, and we have internal, we practice comprehensive quality control, whether it's in a field site or in the lab. Okay, so what are the quality control that we do? Inside in the lab, we do quality control check samples, okay, for our sample, and also calibration check for the instruments, okay, before we run any analysis. And beside on that, we also do the internal quality and check. So why the internal audit and check is important? Because we need to check our current methods, okay, whether it still complies with the ISO 17025. So that's why the internal audits and check is important to maintain the compliance, okay. In a part of that, we have a R&D team that will have like for a new method development, okay. And also we have the quality managers and quality coordinator to actually ensure the quality system in our lab is in place. Besides on that, we also, because we are ISO 17025, okay, we will get this like surveillance audit or reassessment audits, okay, frequently from Standard Malaysia. And also, in addition, some of the clients also like come to our lab for the like for the audits, the client audits, or sometimes the clients will have feedback to us. Okay, what are the things that we need to improve, or what are the things that we need to share with them. And then we have a team of the staff, okay, including chemists, including the lab analysts or technicians. Okay, they are experienced, competent personnel that carry out the test in our lab. And then the last one will be very important is the client communications. So client communications with the lab is important also to ensure the whole process for their samples came in and the result means that delivered to them in a timely manner. Okay, this is our process flow in the lab. Okay, you can see these three quadrants here, or the process here, start from the planning, sampling, analysis, and reporting. All this process flow here is interconnected. Okay, if anything or any broken down of this change, it will directly affect the laboratory data integrity of the results. So later on, like for example, the planning. So how many for the client, how many sampling sites you want to for your samples, and then are you using the appropriate sample container to collect your samples? Okay, then when during the transportation, so did you add in coolant to ensure your samples are chill? And then when arrive in the lab, is the lab means that check against your sample against the COC whether it's correct or not, and everything. Then ensures whether your sample is within holding time or not. Then after that, you will go to the lab for analysis. And if you go to the lab for analysis, we have means that competence personnel to run the analysis, and also with every batch of the samples, we will do the quality control checks. Okay, and final, there will be some chemists to approve and authorize the final result before release to the clients. And all this process is important to ensure the results that we given to the client is accurate and reliable. Okay, the sample containers in ALS, we provide our clients with pre-treated sample container, which is added with appropriate preservative. Okay, which is to actually minimize the loss of the target analyte during the transportations from the site to the lab. And then each of the containers that we provided is customized with the color labels, and then we are packed in the appropriate cooler box. Okay. Before actually the sample container we send to our client, we do a stringent quality control program to check, to check or verify the bottle cleanliness, including the preservative itself. Okay, we need to check the chemicals, the preservative that we prepare. It means that it's free from contaminants before we send to our clients. Okay, so how you should during the sampling, after the client get the sampling, so how you want to know or ensures that the samples that you transport from the site to the lab, the sample integrity is maintained during transportation. So these are the three components that is very important to ensure the sample integrity during transportation. The first one will be the sample preservative, the holding time and change of custody. Okay, the change of custody is important because this is the basic traceability of the sample that the client sampling. So what are the site of identification, the sample marking, the sample ID, a name of the sampler, date and time of the sample collections. So it's something a sampling date. And what are the analysis requested? All this information must be well written in the COC, because if the COC doesn't match with your sample, means that you have a meaningless, you can't get the correct test or correct sampling time, because the sampling time is important to calculate for the holding time. If you don't put your sampling time, the lab couldn't calculate for the holding time for the test parameter. Okay, what is the sample preservation? Okay, it is a physical or chemical process that minimizes the potential loss of the analytes and changes in the sample during the time period from the sampling to analysis. Why we need to actually preserve the sample? Because the compositions of the sample, it can be changed by either it's by chemical or biological or physical process. So that's why each of the analytes, okay, will have their different preservation. Like for example, if you want to do the oil and grease test, then you need to preserve with sulfuric acid. If let's say you want to test for the heavy metal, then you need to preserve with nitric acid. So each of the tests will have a different preservation to maintain the sample integrity. Okay, if you don't preserve your samples, so it means that the result, okay, but that analyzed in the lab is not valid because during the transportations there might be changes in your sample integrity. For examples, for the DBPs product, okay, for the THM, if you want to analyze for the THM, so you need to collect in 40 ml vial with preserved with the HCl. Okay, if for haloacetic acid, the sample need to be collected in 40 ml vial, okay, which is preserved with ammonium chloride preservation. And whereas for the oxyhalite, for example, the chloride is 40 ml with the EDA preserved. And then whereas bromate, both, okay, the oxychloride all is with EDA preserved. Okay. Okay, what is the holding time? Holding time is the time period, okay, during the preserved sample will have a negligible loss of analyte. So it means that it's counted start from the moment of the sampling and end with the beginning of the analytical procedures, okay, such as the extraction or digestion. That's why I highlight earlier in the COC part, you need to write down your sampling, means that your sampling date, because it will, the holding time will be start from your sampling date until beginning of the analysis. I give you examples for the microbiology test, micro testing. Because the holding time is just only 1 day, it's 24 hours. So it means that by the time you do the sampling, you need to be immediately, okay, send the sample to the lab, because the lab need to be means that need to be do the analysis within the means that 24 hours. Okay, some of the compounds may have a longer holding time. For example, if you want to analyze for the heavy metals, okay, heavy metals holding time is 6 months. So with the conditions, you are preserved with the nitric acid. Okay, like for example, if the oil and grease, the BOD. The BOD holding time is just only 2 days. Okay, yeah. So you can see different test parameter will have a different holding time. So this one means that the sample when received in the lab need to be analyzed the sample within the holding time. So those that exceeded holding time, the result may not be valid and accurate. Okay, so you have when you the sample is collected with appropriate sample containers with appropriate preservative, and you write with a full complete COC. Okay, the samples will be sent to the lab. Okay, in the lab, it means that the sample will register in the sample registration site. Okay, the date and time will receive, it will be recorded along with the temperature on the receipt and the sample conditions. Okay, then the sample container receive our cross-check against the COC. Anything and also the requested analysis or any field notes or commands or field data will be entered in the LIMS. So the samples will be registered with a unique ID and will registered in our LIMS system. Okay, clients, okay, after the sample register everything, the clients will be notified, okay, of the conditions of the sample received or any incompliance of holding time or preservations of sample upon receipt in the lab. Okay, in this case, the clients will be received the sample receive notice, which is called the SRN. So once the sample is committed in the lab, the clients will receive the sample receive notification through email. Okay, so what are the informations you can get in the SRN? Okay, these are the information you can get that confirm the receipt of the samples, notify the scheduled reporting date, so you know what is the reporting date, and the sample temperature and the moment of receipt. And the temperature is moment of receipt is important because you need to know that the sample conditions that you receive is better in the good conditions. And also notify the sample container and preservation's non-compliance. So whether you receive the correct bottles with the correct preservations. And also it will show the requested deliverables and provide also the summary of the samples and requested analysis. And this is an example of the SRN, like I highlighted earlier, what the information you can get. So this is is a circle. One is your scheduled reporting dates, what you will receive the result. And you will know that the sample container preservation non-compliance, if your sample is in the correct containers and preservations, so it will show that no sample container or preservation non-compliance exists. If you are breached, means that the non-compliance, so it will show that means that you are not compliant. Okay. Then you can see means that the summary of the sample and requested analysis in the SRN also. Okay, and also the proactive holding time report. If your sample is within the holding time, so that it will show you the notes that sample has been received within the recommended holding time for the requested analysis. Okay. What are the lab QA/QC assessment that we practice in ALS? Okay. Why are these QA/QC are so important? Okay. It is important to ensure that the result of the lab analysis are consistent, comparable, accurate, and within the specific time limits of precision. So what are the QA/QC system that we practice in ALS? So for every batch of 20 samples, okay, our LIMS system is pre-programmed with all these QC samples, which is the method blank, lab control samples, matrix spike, and duplicate, with the conditions that your sample is sufficient to carry out all these QA/QC samples. So this is the table just for your reference. So what is the importance of each of this QC sample then? So, okay, I won't go through the one by one, but it's generally like for the method blank, is to monitor whether there's a contaminations that introduced in the lab. Okay, whereas for the LCS is laboratory control sample is to check the precisions and accuracy techniques. Okay. For the matrix spike is actually you are spiked to a certain concentration to the sample. So in this case, you will monitor whether there's a method bias or due to the interferences of the sample. And then the last one will be the batch duplicates. Okay, duplicates means that your sample it will split into two samples, and then we go through the same procedures to run the sample is to monitor the method precisions. Okay. Yeah, that one is my last slide. Okay, for this for today's presentations, I would like to share with some of these take-home message. The first one will be disinfectants in drinking water can react with the organic material in water to form the DBPs product. Okay, what are the common? Okay, THN, haloacetic acid, and oxyhalides are the common regulated compounds to monitor in our drinking water. Of course, that one is a common, but they are actually more than a lot of DBP products actually in our drinking water. And for the THN trialomethane groups, okay, you know that this is done by the GCMS touch and trap. For the haloacetic acid, is done by the LCMS triple quad. And the last one is oxyhalides compound. It can be analyzed using ion chromatography. And the last one is good quality management system and quality control. Method accuracy and precision is important to generate accurate and reliable data. Okay, I would like to share with you other key testing services that provided by ALS.
ALS Malaysia offers a wide range of analytical testing services, and these are our key testing services: environmental testing, industrial hygiene, food safety testing, biotechnology, medical devices and pharmaceuticals, and tribology. We thank you for your time, and we would like to take this opportunity to introduce our dedicated client service team that has been serving you all this while. Here's a short video from them, and we thank you again for your continual support. Thank you.
Thank you for using ALS services. We are your client service team.
ALS.
Okay. Thank you for all the participants. Spare your time to for this about 45 minutes webinar. Okay. If you have any questions that just now that you haven't asked, you can ask me now. So I would like to. I will be willing to actually to answer your questions if you have it. Or if you have any questions that you're shy to ask over here, you can actually email to me or with our CS team with this email address. Yeah. Okay, I think most of you actually already asked the questions during that earlier break. Then I would like to end these questions. Okay, there are two questions here. The first one is, what is the holding time control for water samples from JB to KL or Penang lab? Okay, because our JBs and the Penang lab, okay, they are also have the means that the lab, okay, that is do most of the critical analysis. Like for example, for the micro testing, that the test need to be done within 24 hours. So we have the lab, means that the micro lab in JB and Penang lab, and also those some of the critical tests like BOD or those that means that the short holding times, that means that those samples actually is done over there, and then for those that some of the tests that not done in the JP or KL, means that the Penang lab, which is not critical for the holding time, means that they were sent to KL lab for the testing. So the holding time here for the critical is not an issue. Okay, yeah. Okay, this is the other questions. May I know what is the average? Okay. How is the procedure if your client requests to repeat the test? Okay. Normally, if the client receives the result, okay, the reports, normally if they have the drop of the results, they will email to our client service team who actually service them. Then he or she will pass the message to the lab. Okay, to the lab, we will do means that raw data checkings, whether there is means that, like, for example, transcription error or anything. After we check the result, if there's no any transcription error and everything is okay, the QC is passed, everything means that we check thoroughly, then we will feedback to the clients. Okay, if let's say the client insists want to repeat the test, we will means that inform the clients whether the remaining samples that we have is still within holding time limit. If let's say if the sample is not within the holding time, we will inform the clients that even though you want to repeat this, means that the samples, the result they produce, means that the repeated result may not be valid because it's already exceeded the holding time. So in this case, if the clients want to make decision to resend their new samples, yes, we will receive the sample and then we will do the repeat testing by create a new means that register as a new samples. It depends on the situations. Okay, yeah. Okay. Is there any other questions? If don't have other questions, I would like to end of this webinar. Thank you for your times for attending this webinar. Thank you. Thank you, everyone.